Okay, so today is, the 1st of February. So you've gotten one kind of naming out of the way under your belt, binary ionic. Binary ionic compounds. And for the most part, if you got a 6 or a 7 on the FIP quiz, I'm assuming that you can write the name of a binary ionic compound. I'm assuming that if I give you the name, you can give me the formula. Binary ionics are the easiest ones we do. Okay? Usually, here's the way this works. People kind of sail through the first chunk, the binary ionics. They're the most straightforward. If you are still having some trouble with them, you absolutely must make some time to come see me at tutoring. I'll probably tutor tomorrow night since I can't tonight because of the department meeting. So Mrs. Hale and I will probably both be tutoring tomorrow. We'll have tutoring up and down. I also will be here Thursday. I will make time someplace else in the week if you need to. Because what's going to happen now is we're going to toss some slightly more interesting kinds of naming at you. And we're going to build these one by one. So you got the easy one. Then we're going to give you one that's a little bit trickier. Then we'll give you one that's a little bit trickier. And then we'll give you one that's not tricky, but by now you have 4 different systems. And they're each okay on their own. Then we're going to mix them all together. Because that's the way chemistry actually works, is you'll have compounds that are named with any of those 4 systems, and you have to be able to identify them. With each one that we learn, you get a FIP quiz, just like we did today. So we learned binary ionic, you practiced it, you took a FIP quiz. We moved on to the next one. We're going to do the same thing. Once we've got all 4 of them, here's what's going to happen. I'm going to give you your compound naming and formula writing quiz. It is a paper and pencil quiz. It is a 15-point quiz. It is not a FIP. Now, this is like a toll gate on a turnpike someplace. You have to pass this quiz. Your toll is passing the quiz. You can take it as many times as you need to, though I have never had a student take it more than 4 times. I think I have 5 versions of the quiz written, and I've never had to employ the 5th. I've got quiz 1, A and B, quiz 2, A and B, quiz 3, A and B. It gets a little bit confusing by the end. The first time you take, so you have to get, is it a 12 or a 13? I think it's 12. You have to get a 12 out of 15. Check my percentage, hold on. So you have to get a 12 out of 15 on this quiz overall. If you get a 13 out of 15 the very first, well, let's say you get a 14 out of 15 the very first time. Great. It goes in the grade book as 14 out of 15 and you're done. You don't ever have to take the naming quiz again. Let's say you bomb the first one. You just totally, man, you make every mistake you can. It happens. So, you do really badly on the first one. You come back, you take it again, you get a 15, so time 1, let's say you get a 0. What do? In the grade book, I record a 0 for your score, and I put in the comment section, first attempt. Now, it's on you to make up that quiz. So if you never come back and try it again, you're getting a 0. I don't like that. If you, well, actually, no, I think I recorded as a missing grade until, yeah, that's how I do it. It's been a year. I recorded as a missing grade, and in the comment section, I'll put 0 out of 15 first attempt. Your job to come back and make it up. It goes in as a missing grade until you get your 12 out of 15. If you come back the second time and you get a 15 out of 15 on try number 2, in the comment section, I will put second attempt, 15 out of 15, recorded as, because the second time you take this, the highest score you can get is a 14. Even if you get 15 out of 15, I will not give you a 15 out of 15. If you have to take it a third time, let's say, you bring this up, but you're still looking at a 10 out of 15. Okay? Still going to record it as missing. Let's say on your third attempt, you nail it. You get a 15 out of 15. The highest score you can get on your third attempt is a 13. So every time you take it, the maximum total number of points that you can receive drops by 1. So if you get a 15 out of 15 on your third, in the comments section, it'll have still recorded your first attempt, your second attempt, your score, and on the third attempt it'll say 15 out of 15 on third attempt, recorded as 13 out of 15. So that's just my little incentive to get you to really, really work hard to get it on the first try. So, questions on that? We good? Okay. We're going to talk about the stock nomenclature system. Okay, so this is the second kind of naming you're going to do. And stock nomenclature is just a system for naming ionic compounds. It is used more widely than we will use it here, and we'll talk a little bit more about that. Really what this comes down to is for elements where they make more than one ion. So this is the transition metals. Because remember, they've got those delocalized electrons. Chromium can make chromium 2, 3, 4, 6. Copper 1, copper 2. And you have to specify which ion you're dealing with. So we do that using the stock system, and it's a way of designating the compound by using the Roman numerals. And we talked a little bit about this the other day. I said, this is like a Grant's tomb kind of question. What's the charge on a chromium 4 ion? 4. And remember, the metals are always positive. So there are a few metals that only make one cation, but I'm about to give you a list of the common multi-ion forming metals. So this is your ion and oxidation number reference sheet. You probably got an oxidation number reference sheet in physical science, but I like mine a whole lot better. I think it's more intuitive and easier to use. From the first year I used this. Students started calling it the Ion Bible. You will use this on every quiz, on every test, on every homework, on everything. This will become an extension of your body. If you'd like to get it tattooed on your inner arm, knock yourself out. That would be kind of, I don't know how you'd manage it. The front is just a plain old Van Brander periodic table like we've been using. The back, however, remember I said you'd be getting something that would give you some help on remembering what forms what ion? Look at the very top. The very first box. Common main group of monoatomic ions. Group 1 makes +1, group 2 makes +2, group 16 makes -2, group 17 makes -1. Never doubt it again. Over here, aluminum and nitride. And the ions they commonly form. Now the next box are the common... Oh, those names got reversed somehow. Okay. Well, I knew that there were problems when this got translated into Google Drive. Where it says common polyatomic ions, that should say common D block and other metal. Basically the title from the next block down. So that should say common D block. And these are the things that make multiple ions. So you can see that you've got copper 1, copper 2. There are a lot of things that make 2+ ions. A smaller number that make 3s and 4s, but they're worth noting. And what you have here is the name of the ion and its symbol. There are a few on here that don't make multiple ions typically. Find me one that does not have a Roman numeral behind its name. Silver. Silver typically forms a +1. Experimentally, is it possible that silver can form some other kind of ion? Maybe, but according to the sources that I've got, it's typically +1. Did you find the other one? Cadmium. Cadmium typically forms a 2+. Again, is it possible that experimentally somewhere it forms some other ion? It is, but the sources that I've got show cadmium pretty much always forming a 2+. So how do you use this? Let's do some examples. So when you get something that is a transition metal that has multiple ion possibilities, here's what you're never going to see. You're never going to see, oops, this is zoomed out like that. Copper oxide. You're also never going to write copper oxide. Do you know why? Because that doesn't tell us which copper oxide. You always have to specify whether you're talking about copper 1 or copper 2. So you're going to have, oops, something like that, copper 1 oxide. So we'll practice the easy thing first, which is writing formulas when you're given the name. So when you're given the name of a transition metal compound, an ionic compound using a transition metal anion, the process is the same as it was for the binary ionics. You're going to write the ion, so this is Cu with what charge? Hold up your fingers. 1. Why is it 1? How do you know that? Because it says 1. Yeah, it's a Grant's tomb kind of question. It is that easy. So this is Cu1+. Now, oxygen. What ion does oxygen typically form? And you can look at the top. What group is oxygen in? -2. So this is going to be O2-. And here we're leaving room for our subscripts. We're going to do that crazy crisscross thing. And we have Cu2O1. Take your 4 minutes and we'll meet up back here. So we had done the crisscross. We've got our charges written down here. And of course we can simplify this. So we're never going to write a 1 as a subscript. That's the clarification. We never write a 1 as a subscript. So this is Cu2O. Okay. Copper 1 oxide is written as Cu2O. Now, let's do something slightly more interesting. I know everybody gets nervous when I say more interesting, don't they? I'm sorry. Let's do titanium oxide. I bet you guys have used titanium oxide. Anybody ever use sunscreen that leaves a big white smear on your nose? It's got the it's the stuff that really coats you and looks like you've got clay on your nose. That's a titanium oxide sunscreen. Okay, so let's do titanium 3 oxide. And I don't know which ion of titanium is used in the titanium sunscreens. But anyway, let's do titanium 3 oxide. So again, we're going to write the ion, Ti. What's the charge on titanium 3? 3. Oxide ion, what's the charge? 2, yep, 2-. So we have 3 plus 2-. Ti with room for a subscript, O with room for a subscript. Do the old crisscross. And we have Ti2O3. That is the formula for titanium 3 oxide. So let's look at lead 4. I don't want any lead in my peanut butter sandwich.
Said the people of Flint, Michigan.
Well, yeah, I was going to try to not go there. Anyway, lead is Pb. So if we have lead 4 oxide, lead 4 oxide, write your ions. What's the lead 4 ion? It's Pb 4 plus. Oxide ion, we've only written this about a half a dozen times so far. O 2 minus. Pb, room for a subscript. O, room for a subscript. Crisscross. Are we done? What do we have to do? Simplify. Lead 4 oxide is PbO2. Yes. Why do we simplify? Because ionic formulas are just a ratio of charges. So 2 to 4 is the same as saying 1 to 2. Just like 2 to 2 is the same as saying 1 to 1. 3 to 3 is the same as saying 1 to 1. Let's do something. Ooh, let's do something crazy. Crazy. I don't even know if this compound exists in the world. Let's do cobalt 4 nitride. So, what's the cobalt 4 ion? You've got your cheat sheet. CO4 plus. And all of the D block stuff, actually everything you need is found on the back of that sheet right now. So we've got CO4 plus. What's the nitride ion? It's right up at the top of your reference sheet. What is it? N3 minus. CO, room for a subscript. N, room for a subscript. Crisscross. Can it be simplified? Nope. CO3N4. I've actually never seen that compound referenced anywhere, so I don't know that it can exist, but it's fun to write. Okay. How easy are these? Or where are you at with these? 0, what's your name? 5, yeah, I'm ready to take the quiz. Okay. These are fairly straightforward when you're going from a name to a formula. As I say that, do you suspect that there's a catch? There's always a catch. Sorry. So I agree. Going with stock system, going from a name to writing a formula is pretty darn easy. The trickier part is when we go from a formula and I ask you for a name. So let's do this one. If I give you CuO, well, no, let's not start with that. Let's start with Cu2O. I need to write a name for this. I'm actually going to move this down a little bit in the middle of my screen. So we know that this is copper something oxide. And you are going to use this reference sheet every time that you are looking at formulas and naming, because if it's anything that appears in that middle block, the common D block ions, you're going to know that there has to be a bracket in the middle that specifies the charge on the ion. So you're always going to say to yourself, oh, this is, iron something sulfide, copper something oxide. You're always going to leave that space. Now, how do you figure out which copper it is? For some of you, if you've got a really mathy brain and you see ratios easily, you may immediately go, oh, well, it's taking 2 to balance out 1 oxygen, so this is copper 1. Okay. For the rest of us, I do what's called the reverse crisscross here. So in order to figure out which copper ion we're looking at, we have to think back to what the charge on that copper would have been. Whoops. And we know that the copper would have had a positive charge, and we know that the oxygen would have had a negative charge. And if we take these numbers, and there's no number here, which we know means a 1, we get a Cu1 plus and a O2 minus. Is a negative 2 the charge we would expect on oxygen? Yes. Oxygen makes a 2, it's a negative 2. So what copper compound is this? This is copper 1 oxide. Okay. Let's do another one. Let's do Fe2O3. Okay, so what do you know this is? Iron something oxide. And interestingly enough, iron oxide comes in two colors as well. There's a black form of iron oxide and what we would think of as a rust-colored form. And in the wild, rust is a combination of the two. So I can never remember which is which. But okay. How do we figure out which iron we're dealing with? We do a reverse crisscross. So I'm going to move this down. And iron would have been a positive ion. Oxygen would have been a negative ion. So if we reverse our crisscross, we get Fe3 plus O2 minus. Is 2 minus a common ion for oxygen? Yeah. So what is this compound? It's iron 3 oxide. This is iron 3 oxide. Do you want me to tell you what the common mistake for this is? Going, oh, okay, it's iron 2, cool. And using that subscript that's on iron as the name of the compound, don't fall for it. It is not iron 2 oxide. You have to reverse crisscross. Unless you are a real natural at seeing those ratios immediately. And, I mean, here's the thing. If any of you are headed off to a chem minor or a chem major or a pharmacy program or a biochem program or anything else where you're using chemistry every single day, whether you're a natural at seeing those ratios off the top of your head now, you will become one. You know, you spend a year doing general chemistry in a lab someplace, and you're not going to ever have to reverse crisscross or even think about it. It's going to be completely intuitive. But right now it's not. So I'm giving you tricks until it's intuitive. And then you can come back and visit me and go, oh, that's fine. Okay. I'm going to do one more that's relatively straightforward, and then we'll do the tricky ones. Okay. Let's do MnCl2. So what is this stuff? It's not magnesium, don't fall for that. Who's got it? Manganese. It's fun to say. Manganese something chloride. So again, we got to do that reverse crisscross. We know that manganese, it's a metal, so it would have been the positive ion. Chloride ions are negative. We reverse crisscross. There's nothing there, which means we must have had a 1. So this is what compound? Manganese 2 chloride. Zoop, zoop. Okay. Okay, SNO2. What's the basic sort of skeleton for the name here? Remember, I've got my tin snips. Tin something oxide. Okay. So I've got tin something oxide, And if I do a reverse crisscross, we know that tin had to be a positive ion because it's a metal, and oxygen would be a negative. And I take my little numbers here, and I say, oh, well, this would be a 1 and this would be a 2. I see a few people going, Is 1 the ion that oxygen commonly forms? No. What ion does oxygen commonly form? 2 minus. What happened here? It was simplified. So we guide off of the things that we know. And oxygen in all but one compound has a -2 charge or oxidation state. So if that's a 2, then this must be what? 4. Sure enough, this is tin 4 oxide. So you have to pay really close attention. Oxygen and sulfur and the halogens are really easy to cue off of. Halogens always form what? Fluorine, chlorine, bromine. They always form a 1 minus. They always gain 1 electron. So, and I can't really think of an example where the halogen would be a giveaway. But oxygen and sulfur, the oxide and sulfide ions, are always 2 minus. So be on the watch for those. If you come up with, oh yeah, sulfur is a 1 minus charge. No, it's not. That should set an alarm bell ringing in your head, and you know that there was a simplification. So let's do one more tricky one. We'll do lead sulfide. Oh, yeah. Yeah. Okay, we got lead sulfide. So I gave away the sort of skeleton of the name. We know that this is lead something sulfide. And we do our little reverse crisscross. We know lead's going to be some kind of positive, some kind of cation, and we know that sulfur is going to be some kind of anion. And neither of them have a number, which means these are both what? 1. Hey, great! What's the problem? Sulfur doesn't form a -1 ion. Sulfur and oxygen are pretty universally 2 minus. So what happened? Simplification. So this must have been lead what?
2.
Lead 2 sulfide. You want to do one more like that, or do you see the trick and you just want to be cut loose to practice? Who would like to just be cut loose to practice right now? Okay. A few people who are not responding. I got about half the class who's not saying yet. Okay, so I will print out the practice sheet. Same format as today / Friday. You do the practice, you check it when you come in tomorrow morning. Well, actually, let me get you the practice sheet and then we'll talk.